In this video, we're going to work on the ALEKS problem called identifying the parts of a glycerophospholipid. There's two different components to this problem. It's asking you, first of all, to identify what type of molecule it is. Don't be tempted to say glycerophospholipid because ALEKS wants a more specific answer than that. We'll come back to this, this part of the problem. We'll do this part last. The second part tells you that, or asks you to identify the 4 different components that are making up this glycerophospholipid. It's got them color-coded, corresponding to the diagram. Let's start with that part. Glycerophospholipids do have 4 pieces to them. One of them is the glycerol backbone, which is shown here shaded in blue. And you want to write that into the box that corresponds to box B, which is the glycerol. Now, there are also 2 fatty acids in each glycerophospholipid, and you're going to identify those 2 fatty acids using ALEKS's data table of fatty acids. So if you go over here to this part of ALEKS, you can pull open a data table. I actually have the data table up here on this side, so we can use it to reference to help us answer this question. What we're doing is looking for a fatty acid that matches this particular structure in terms of its carbon skeleton. It's going to be a little bit tricky because this is in condensed notation and the ALEKS data table, as you can see, they're all in line notation, but we'll be able to figure it out. We're looking for, we'll do this one first. We're looking for a fatty acid that has one carbon-carbon double bond kind of in the middle. So perhaps like maybe it's this, maybe it's this. We also need to be able to count how many carbon atoms there are to help us identify exactly which one of these fatty acids we're looking at. So I can see here, starting at the carbon-oxygen double bond, I have 1 plus 7 more carbons, 1 plus 7 plus 1 more, and then 1 more, and then 5 more, and then 1 more. That adds up to, like, I think 16 carbons. 16 carbons total, with a carbon-carbon double bond starting on number 9. So I'm looking for 16 carbons total. Let's try palmitoleic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got pretty lucky. So this first fatty acid, which is C, I've got it kind of cut off in the picture there, but it is C, that is palmitoleic acid. Palmitoleic acid. And one thing I want to point out, in the ALEKS data table, it just says palmitoleic, but it's just abbreviating the name. ALEKS does want you to enter the acid portion in the name. So same kind of a thing, we're going to look for second fatty acid. This one is almost exactly the same, it just has 2 extra carbons in it. Maybe it is, I want to say maybe it's oleic acid. So it's going to be 18 total carbons with a carbon-carbon double bond starting at number 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, oleic acid. So this is oleic acid. Now, the last portion that we need to identify is the portion that's highlighted in pink over here. There are 3 different options of what this portion of the molecule could look like. This particular portion of the molecule is the molecule serine, and that's what we want to put in the box down here. And the name of the glycerophospholipid is actually based on which molecule we have in position A. Since we have serine in position A, the name of this glycerophospholipid is phosphatidyl, hopefully I got that spelled right, serine. Now, all of these glycerophospholipids have the same beginning of portion of the name. They're all phosphatidyl. And then the ending of the name, serine, for example, is going to be based on what molecule you have in position A. So what are your other options? What else could you see in that spot instead of serine? One other option that you could see is going to look like this. And this is going to connect to the phosphate group right here. I'll just draw part of the phosphate group in. This portion, if you have this particular portion, this is choline. And so you would enter in choline here instead of serine, and the molecule's name would be phosphadidyl choline instead of serine. And then the other thing that you might come across, let's squeeze it in over here, is also an amine. Looks like this. Here's the phosphate group, like that. And this molecule's name is ethanolamine. So if you have this portion in the pink spot, in the pink box, then ethanolamine is the name of the molecule that you would put for A, and the type of molecule would be phosphodiethyl ethanolamine.